Hello, this is an integrative project in presentation about the BioMass pellet mill machine. The team members are Felipe Calderón, Héctor Casas Hernández, Edgar Arturo Gamboa, and Jorge Alejandro Granados. So first of all, what is the biomass pellet mill machine and what are the pellets? Well, biopellets are an alternative type of fuel that is recently being used as a fire starter in some cases or as a complete fuel source. It is being mainly produced by big companies, especially in China. And the reason we decided to build a biomass pellet mill machine is because it is not currently used as a renewable source of energy compared to other that are not produced with recycled materials as the biopellets are. Since our machine is mainly focused to recycle the waste that is being produced uh, by the sawmills or even local carpenters or any waste that is produced out of wood. Mainly because the existing machines are really expensive and we seek for an alternative for more local productivity. Um, the primary source of materials or components are wood, wood chips, or even waste paper. The pellets are very flexible when it comes to uh, making making them out of any type of um, waste, and they have a really good consistency. And what is more important is that they produce very little contamination or pollution compared to other uh, fuels. Not to mention, they are quite easy to make and very easy to handle. Uh, they also can be transported more easily than the biomass mixture, which is kind of difficult to handle because of the humidity. Now, a few of the drawbacks are that it is still a burning material, and it comes mainly from biomass, which it may lead to an excessive cutting of trees or excessive production of the material. So even though the goal of this project is to have an environmental impact, well, at least a positive one, it might result in some undesired situation. However, since it is really not the most ideal fuel for industrial purposes, we think that should not be a problem, and that it's actually going to have a positive impact. Now, there is little to no market for bio pellet mill machines uh, in currently in the local market. So we also aim to promote um, the machinery production of small pellet mills. Because even though they have a relatively small production compared to a bigger machine, they are easy to operate, maintain, and they also are movable, more economical, and environmentally friendly.
Let's start talking about the top, the design area where all the materials are going to be mixed. Here the first thing that will be observed is a lid design with a handle to add all the materials inside the mixer. There is also a heat and humidity control inside it because all the materials need some percentage of this for its optimal operation. Underneath is the axle support, a steering wheel type support that will be attached to the top of the machine with a 5/8-inch internal diameter bearing. The following will be the paddles used to mix the materials. A series of 10 cm long steel sheet paddles attached to the shaft by a clamp. This allows us to avoid drilling the shaft and compromise its resistance. This area will be separated by a thin aluminum plate which contains a perforation that allows the passage of all the already mixed material. This also contains a cover with the same material that closes that perforation when necessary. In the center of the machine, where the biggest part of the shaft is located, we have the extrusion area. Here is where all the mixture is going to be extruded and converted into the pellets form. Starting this area, we find the rollers, which are in charge of compressing all the mixture. These are two gear wheels with the same size, and these have their own axis crossing the biggest part of our shaft. Under the wheels, we have the extruder plate, a steel plate which has 3/8-inch perforations through its surface, where all the mixture is going to pass through and gain its pellets form. This plate does not require movement because of the rollers are the main part that are going to be moving, pushing and compressing all the mixture through the holes of the extruder plates. At the bottom of the machine we have the cutters and the area that ejects all the already finished pellets. The first thing of this area are the cutters by themselves. These are two more steel sheet paddles attached to the shaft. These are varnished on the top side to give them a certain shaft edge that allow them to include the structured mixture, also cutting the pellets at certain length. At the bottom of the structure we have another thinner steel plate, which is used to be turning and removing all the cut pellets from the machine towards the object that will be used for their storage. All the pieces of the machine are assembled in a table made of aluminum and profile where our motor is going to be fixed. Talking about the costs, the motor and the PLC are the most expensive parts, having a total cost of 9,000 pesos and giving us a final price of our project of around 14,000 pesos. Besides it could sound like an elevated cost, the most of the semi-industrial machinery that's actually on sale could have a price of around 50,000 pesos to 100,000 pesos. The designing process of the axis were really interesting. It is known by the fact that torque is transmitted proportionally amongst the whole cylinder. However, we could not have a uniform cylinder because it would decrease the machine efficiency and not concentrate the force where it was mostly needed. But on the other hand, not a big variation could be made because it would create a stress to completely break the axis. Following books and with the help of several university professors, an Excel document was made to calculate the weight of each section of the axis. After the median weight was calculated, we looked for the aluminum ultimate shear modulus and calculated which was the maximum width of cylinder that we needed to have. According to our weight and torque table, the design diameter for our cylinder was selected in a 1 inch. With the main diameter already selected, we were able to establish the sections with different circumferences on the cylinder. Once the measurements were made, once again with the help of Excel, a table was made to showcase shear stress to reassure the shear modulus would not be surpassed, translating in the axis breaking. Despite all the data collected and analyzed, as the axis is considered a dynamic body which will bear dynamic cutting, stress and pressure forces, the possibility of the axis breaking is in fact present.
Hi everyone, I'm going to talk about the control part of the pellet machine. First of all, we're going to be using a programmable logic controller, which is a PLC. We're going to be using the PLC 1200 of Siemens. Related to our inputs and outputs, we have three digital inputs, which are two buttons in order to control the start and stop of our machine, and one limit sensor that is placed at the top of the machine. This sensor, its function is to letting us know whether the top door is already closed or not. After that, we have two analog sensors. Those sensors will measure the moisture level within our mixture. It is going to give us a voltage from 0 to 5, which we are going to escalate and normalize within our PLC program. After that, we have 4 digital outputs. One of them is for the motor, which is controlling the cutting, compression, and mixing part of the machine. Also, we have a middle door that is to control and separate the mixing part from the compression and cutting part. And also we have our dry and add humidity to our moisture so we can adjust at the values we want for our mixture. In order to be controlling our machine, we're going to be using this flow diagram. So the first things we need to do is to power up our machine. Even though it has already been powered, it's not going to start working until the operator tells it to. Once it's already done that, the first thing the machine is going to do is close the middle door. This with the purpose of separating the mixture part from the compression part. Also is going to wait for the machine to the top door is closed, which will mean that the materials has been already poured into. Once the material has been already poured into, what the first thing we're going to do after is to start mixing for a little time. This with the purpose and the idea of getting an average value within our mixture. Once we are done with that, we're going to check the level of moisture. In case that we're looking to have a 10% to 8%, in case that is higher and is really far away from it, we're going to take away moisture from our mixture. And in case that is too low, we're going to add it. The idea here is that we are around those values. We are certain tolerances and we should be within those tolerances. Once we got the right values, the right moisture, we are going to open the middle door between the phase of compression and mixture. This will start make the machine to pour our mixture into the compression and cutting part, which will give us the result of the pellets which are properly done. After this part is done, the machine is going to stop working and is going to wait until new and more material is added so the process can start all over again. And this is going to keep going until there are enough pellets or there are no more materials to be working with. And that will be all for the control part of the machine.
Hi, my name is Dr. Casas, and I'm going to explain our conclusions for this project. First of all, our machine is way cheaper than semi-industrial and industrial machines available in the market. Our machine costs less than half of the cheaper machines that we could find. Then it automates two processes. The two processes that we are joining in one compact machine is the mixing and the dispensary of the pellets. Then there's a lot of room for improvement. Our machine is a prototype, and we know there's a lot of areas of opportunity and improvements that with the joining of several ideas, we can make our machine way better and more efficient. Then, and it's an excellent alternative for micro or small businesses, also for entrepreneurs or just ecologists who want to start their own biomass pellet business, or they want to create their own at home. And it foresees the energetic future. This is one of the key components of our project. We cannot longer just work with fossil fuels that are damaging our planet very badly. We need to see new forms or new alternatives of working or heating ourselves. And these pellets, these biomass pellets, are the perfect alternative for future fuels. Then we have a lot of perks for the user. First of all, it's great for the environment. It only requires for it to be plugged in into electricity, and all the materials that you need to use for pellets are recyclable and easy to get. You're not going to create carbon emissions because of gas motors, and you're not going to overuse your electricity, which is great. Then it's very cost effective. It's the revenue that you can get by selling or just by using your own biomass pellets. requires that in less than a year you're going to be recovering the cost that you put into the making or into the buying of these types of machines. It's very easy to use. You just need to pour the different ingredients into the machine, press start, and wait for a machine to dispense the biomass pellets. It's very easy to maintain. Our prototype does not has integrated design, which parts that are hard to get. You just take out the handles and all the machinery is available to you. Feature friendly. This means you do not require a special electric or flooring distribution because it works with 110 or 220 volts. And the floor does not, because it does not vibrate, it does not require a special flooring. It adapts to the ecosystem you're going to be working within. And it's very powerful. Because it's 1 horsepower equipped, you are going to be able to carry big loads of biomass in order for you to make a lot of pellets. And finally, areas of opportunity. We know our budget was limited with this project, so a lot of the rooms of opportunity or a lot of the areas of opportunity has to do with the budget. First of all, the chassis. We know we use aluminum buckets because it was the materials that we had in hand. But we can use a lot of newer and better materials for the machine to have a better presentation. Of course, this will not be possible without the correct funding or without the correct money. Then we have the separation mechanism. Or desired separation mechanism only requires in a small hole or in a small plate with a hole that will open and close with the help of a 4-leg mechanism. However, we know we can make this even further. We can make the hole even bigger, or we can make a complete plate that will just open outwards of the body of the machine. Then we can, as I said, the component quality was mainly limited by your budget. But with the correct budget or with the correct funding, we know we can invest in better and lighter materials that will cause the machine to be way more efficient. Also, we were planning on adding a human-machine interface. Right now, we're just working with a PLC that's going to be enabled into the machine. However, in the future, we can add an HMI to further make the mixtures or the way of working way more customer friendly, or we could customize the HMI according to each customer or each needs of the industry we're going to work for. We can make added capacity, we can make bigger machines with the same principle, and one of the future of our machines, we are looking forward to automatic material pouring. The automatic material pouring will be great because we were planning on just sensors that will measure the amount of materials, and you will not have to pre-measure before putting the mixture into the machine. So that will be a great addition to do in the future. Right now, I'm going to show you a little bit of the physical advancements we have over prototype. It's way important for you to notice that we almost had all the parts of the prototype completed, just ready for assembly. However, we could not do a lot of the things that were required because the machinery available at school was not enough or was not powerful enough to obtain some of the results that we wanted. But I'm going to show you how our physical advancements went before everything closed down for this pandemic.